Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 4, Lesson 3, on the different ways to factor polynomials. Something to note about this lesson, well, one thing, is that these are showing you the different ways that you'll have to do it. Which, I kind of talked about some of these, and maybe I had used different names for them in the last unit, but these are still relevant, and even these might be helpful if you somehow haven't done quadratics yet, but you kind of have to do that one first before you do this anyways. So, remember, factoring is kind of the opposite of when you have everything multiplied out. You're in some cases you are dividing, but it's kind of just doing the opposite of distributing. It's like undistributing and making it like before you multiplied the things together. So that's what it is. And there's 4 specific ways that you will need to factor different polynomials. And remember, those are just, I went over this in the last 2 lessons, but those are different expressions with various exponents, but that's not what I'm talking about in this one. So you need to know when you use certain ones and how to. Now, there will be the next lessons. This will be for lesson 4, 5, 6, and then 7. Because I'm just telling you an overview and how you know which one to use. And then in the separate lessons, it will show you how to do it. So, I'll also tell you what they are in here. So, sometimes you have to use 2 just for one thing. But how you know that it's factored out is if you can't possibly do any of these things. So the first one is greatest common factor. What does this mean? You use this method when there's a polynomial where you could divide something by each of the terms. Here's an example. Let's say you have 2x cubed, or, well, let's just for the sake do 2x squared plus 14. And here's how you would do it. Well, I mean, I'm not going to actually show you how to do it. That's what I'll do in the next lesson. But when you have something like that, you can see that you would be able to divide by 2 for both terms. But you can't use this method unless each term can all divide by it. So if I added, let's just make this an x, and then I did 5, then you couldn't divide by 2, because 5 can't divide by 2. Well, it can, but it just can't do it evenly, and that's what it has to be. Now, I say by grouping or not, so you already maybe learned how to do this in the last unit, but grouping is a different thing, and I'll show you that on the next lesson. But sometimes there can be 4 terms, and this is usually what the case is, and I'll go over this more. And let's do plus 5x minus 4. Or plus 4. Obviously, this wouldn't actually be a valid example, but what you have to do, you can divide something by each section, which this isn't a valid example like I just said, but okay, now it's not drawing anymore. I don't like this one as much as the other one I used. So that's another way you could do it, but we're talking about that in the next lesson. But basically, if there is terms that all can divide by something, you use grouping. Or I mean, you can use grouping, but just greatest common factor. Now, the add multiply technique, you use this when you usually use this when there's just 3 terms. Actually, that's the only case you can do it. And you can only do it if the first term, if the term has a 4 or a 2 on it. So, like, I mean for the exponent. So, we already saw that with quadratics. We could have something like 9x squared plus 2x plus 7 or something. And then this once again is not a valid example, but what you would do is, well, because this is a 9 and it's not just x, you have to multiply it by 7, which would make it 63, and you have to find something that 2 numbers that multiply to equal 63 and add to equal 2. There's Well, actually, there might be some. Let me think. You might be able to do something with 7 and 9. Let's see. Well, no. That's only if this happened to be a -7, then that would work. But we're talking about that more in that lesson. So that's how you know if you can use that one. If basically there's 3 terms, and you can use it when there's a 4, but not if there's those situations don't apply. Difference of squares. You can use this one when there is well, basically if there's something like this. 9x squared plus 36. You can use this because you have to be able to, you can only use this, or sorry, actually that would have to be minus. You can use this only if you can take the square root of both numbers that are there, which the negative isn't attached. So you can get 3 squared, basically 3 squared x squared minus 6 squared. And then that would turn out to be 3x plus 6 and then 3x minus 6. Basically. But this can only work if the 2 terms, you can take the square root of them. Also, only if this is a minus sign. Because if it was a plus, you know that 2 things, like if you multiplied them, that were with a plus, then there would be no way to get the minus. It's kind of hard to explain, but I'll explain it more in the next, or the lesson 5. So that is how, when you do that, and then once you take the square root of both numbers that you see, you make one, the one without an x, one with a plus, and one with a minus. And once again, we'll go over that more. Sum or difference of cubes. This one is where you have something, it's kind of like the same with the last one I showed you, number 3, here. But this one, number 4, you can use with a plus or a minus. So we could have this. I don't know, this thing's not drawing. Draw. Okay, this thing's so dumb. I really hope that I can find something better to use. So, in this case, you can take the cube root of both things. And it doesn't matter if it's plus or minus. And there's a certain equation that you use that we'll talk about. But that is basically the 4 different ways to factor and a little bit about them and when to use them. So, as a review, you use number 1 if you can divide each term by something, or if there's 4 terms, you can group them by the first 2 and the second 2. And then use the add multiply technique if possible. Usually that's when there's 3 terms, but if the first term there's a coefficient that's not 1, then you have to multiply it by the one with no x on it, and then later on divide by that, but we'll talk about that more. Use the difference of squares if there's 2 terms that this one without an x has a minus sign, and you can take the square root of both. And then you use the difference of squares if there's 2 terms, and you can take the square root of both of them, and it doesn't matter if the term without an x if it has a plus or minus. So that's it for this video. Thanks for watching, and I'll see you on the next one.